All right, are we ready to go?
Yes, I think we'll go ahead and let everyone, I see more people joining us, but I'll go ahead and start. Hello, everyone. Welcome. I'm Gary Bittner, and I'm chairing the IFMA Orange County webinars. These are a series that we're putting together monthly for business partners and the IFMA members to learn more specifics about different technologies and different services that our business partners here in Orange County provide to the IFMA membership. Today we're presenting HVAC systems, and we have our speaker today who is a pinch hitter, Jason Ness. And Jason, if you could introduce yourself, and then we'll go ahead and get those slides started and move forward. If you have questions, please put them in the comments or in the Q&A area. I'll go ahead and manage that and ask the questions. So take it away, Jason, with air control systems. Thank you.
Hey, good afternoon, everyone. Like I said, my name is Jason Ness with Air Control Systems. I've been in commercial HVAC for 21 years. Spent the last 4 years on the control side as a controls manager, doing all of the, basically overseeing any type of controls installation from bidding the jobs to installing them and programming. So we're going to go over a few things today. Topics: HVAC overview, what's on your roof in your building, what's in the plenum. We're going to talk about COVID and the air quality, and what can be done to assist in employees returning to work, how to create peace of mind for the executive teams and employees, risk management issues and mitigation, and the question is, how long should these new policies last? We're also going to talk about preventive maintenance, what to look for in a maintenance program, filtration, a big thing right now with COVID, what's new, what's old, and what you should know, and the preventative maintenance effect on equipment. And then we got some links, to help your FM success.
Jason, you might want to explain why you're not Sergio De La Torre, which Sergio is out sick today.
Yeah, Sergio is out sick, so I got a call about 15 minutes ago and said, hey, jump on in. So here I am. So I'm a little unprepared, but so bear with me. The next thing, we're going to go through the different types of equipment. Like I said, what's on your roof, what's inside the building, the different types of HVAC units, package units, split systems, VAV systems, water source heat pumps, boilers, cooling towers, and chillers. Next slide. This is just a picture of your typical rooftop unit. This is basically a self-contained unit. We have all of the components needed for cooling and heating. So we have usually they could be a heat pump where it uses refrigerant as a cooling and heating source. So we have gas-fired package units where we have DX cooling, and then gas-fired heaters for reheat. We have the RT will consist of a supply fan. We have condenser fan, compressors, all the boards for logic, economizers for outside air, filtration racks, and condenser pans to catch any condensation, and then we'll have a furnace if it's a gas-fired RTU, or if it's a DX system, we're going to have a just a reversing valve that will change the reverse of flow for the refrigerant.
What's that valve? Let me interrupt real quick there. So what's that valve again? A VFX?
No, this is the reversing valve.
Reversing.
So this will change the direction of refrigerant. Usually we're removing the heat from inside the building and expelling it out. When we go into heat, we actually reverse that, and then the heat is sent into the building, and then we'll have almost a cooling effect on the outdoor coil.
And how long should a system like that on a rooftop? Should it last 5 years, 20 years, 50 years? What's old? What's not old, and what is old?
It's kind of a open question. It all depends. Big things that are going to play into a factor: runtime, preventative maintenance, the location. Obviously, if we're closer to the beach, the salt water will have an effect on the units, deteriorating the coils. That's why it's always important to, on a new replacement in that area, is to coat the coils to prevent that deteriorating, that premature deterioration of the coils. But I'd say on average, we're looking at about 15 years life expectancy of a rooftop unit. Like I said, there's variables that will play into that. Like I said, as far as runtime, the area, and obviously preventative maintenance. If the maintenance isn't kept up, obviously we're going to put a hard load on that unit, and then just more or less drive it into the ground if it's not taken care of properly. The next slide is basically just cutaways of these rooftop units. So you can see they have the compressor, the condenser fan, we have a supply fan, control section. The unit to your left, that's a heat pump, or a heat pump RTU, and then the one to the right is a furnace. You can see the cutaway of the heat exchanger. And there's those two different types of units. These are generally constant volume, although some of the newer units will have ECM motors, so they'll have like a variable speed motor, and even some of the larger rooftops will have a variable frequency drive. Generally see those more on the VAV applications, but on the newer units, we're starting to see more of the VFDs. And the benefit of a variable frequency drive versus just a across the line starter is the load you put on the electrical as far as starting it. When you have a variable frequency drive, you can ramp that motor up from 0 to 60 hertz, versus on a across the line starter, you're just going to enable that contactor and pull 60 hertz right off the bat. So a big electrical drain on that type of starter versus a variable frequency drive. So variable frequency drive is definitely a thing, and that kind of is used in all of these pieces of equipment we'll talk about, from the RTUs, the splits, the chillers, the towers, pumps. Any type of variable frequency drive is definitely going to increase efficiency and lower the energy costs. Next thing we'll go over, split systems. Two different types of split systems that we have. One is going to be a ducted split, and that's going to be something similar to the train air handler on your left, and then the ductless split over on the right hand side, with the cassette style air handler. A split system is basically that RTU, and you're kind of splitting it in half, and you're putting the condenser section outside the building somewhere. It's generally on the roof. I've seen them on the side of the buildings. But you'll have refrigerant lines that run from the condenser down to the air handler. These types of system are used in multi-story buildings where you don't have the space to run ductwork. Say from a 3-story building down to the first floor. So generally they'll have a split system because it takes very little space inside the building between the two devices. Like I said, we have a copper line set and some communication between the two. So the benefit of the split system is you don't lose a lot of your square footage inside the building like you would with an RTU, that you have to have ductwork running from that rooftop unit down into the space.
So, and Jason, the facility teams a lot of times do see these split systems used supplementally for server rooms and specialty cooling areas.
Correct. Yeah, we use a lot of them in the ductless split systems. We see a lot of those in data rooms, server rooms, electrical rooms, and it's also, we've seen it sometimes on retrofits, yeah, supplemental cooling where maybe the tenant is has, you know, after hours usage in the building, and instead of running an entire system, you know, maybe 100 tons of cooling on a you know, a floor or a couple of floors, you can use, you know, they generally range, I think, 1 to 7 tons on the ductless splits. So you'll be able to have that after hours cooling without having to run an entire system. So definitely energy saver. These also on the ductless splits and on some of the ducted split systems, those also have variable speed motors. They'll have variable speed fans and variable speed compressors, which is also a really, you know, useful thing for energy costs. So that definitely knocks down the savings when you can vary the speed versus having to run a motor at 60 hertz. Any questions on the split systems?
I don't see any. There's got to be a good question out there eventually. I know someone's got one. It's usually me.
All right, well, we'll keep going. Next thing we'll get into, boilers. Generally going to see these on a larger commercial property because they are going to be part of a VAV system. The boiler will be used in a VAV system to reheat the building. So on a VAV system, you have a cooling only RTU or a VAV boxcar unit, or a built-up system with an air handler. And so how that system would work is, you know, we're generally putting anywhere between 55 to 60 degree air out of the VAV unit, whether it's an air handler or a boxcar unit, and that air is distributed throughout the building through multiple boxes, which we call VAVs. Well, within these VAVs, they have a hot water coil, and so that hot water coil, when that's energized, we run hot water through the coil, and then we'll reheat that air from, say, 60 degrees up to somewhere around 100 degrees, and that will provide heating inside the space. Generally, on the reheat, we only see that on the exterior zones. All of the interior zones are generally cooling. Obviously, you know, cost is that factor. That is why they just have it on the exterior, and that generally does the job of keeping the building comfortable. But a full, you know, VAV with every reheat coil is going to be the ultimate satisfaction for your tenants, because they'll have full control of heating and cooling, versus some areas where on the interior, when you just have a cooling only box, it's always going to be dumping a little bit of cool air, and the heat or the you know, warming up is going to be dependent on those exterior zones. You know, body heat, lights, computers generating heat in the building should keep the spaces at a comfortable temperature. But there's always those occasions where, you know, everybody runs at different temperatures. So having a reheat coil at every VAV, you know, will give you that ultimate control of heating and cooling. Boilers range, obviously different sizes for the different tonnage. And then with the boiler, we're always going to have pumps, because the, you know, this is a hot water system. So we use the pumps to push the water through the boiler and then down through all the reheat coils. And on the reheat coils, part of the VAVs, we'll talk about those and in a few more slides on how that works and what it looks like. And on a boiler, Same thing on the lifetime. It will all depend on the runtime. Generally, there's not a lot of moving parts in a boiler. The biggest probably expense to the boiler is replacing the burners, but that's a simple fix that'll keep that boiler operating at its maximum efficiency. And obviously maintenance plays a big part into that, how often they're being cleaned, if they're being checked. There is a filter that's a part of this boiler as well, because we're pulling in outside air, another important thing to keep clean. And then we want to maintain those pumps, so we have a couple pumps that are used for the main building pump, and then we'll have a circulation pump for the, generally most of the systems are primary, secondary piping on the boilers. So essentially we'll have two loops, the main loop and then the boiler loop. Any questions on boilers?
Probably not. Not a lot of boilers in this group.
All right. We have more of the water source heat pump.
I'm not even sure. I would have thought package units, a lot of package units, and a lot of split units with this group.
Yeah, okay. I know Orange County is famous for their water source heat pumps.
Any takers out there with water source heat pumps? Just say yes in the comments. Or DK if you don't know what that is.
So the next slide, or we're going to talk about our chillers. Different types of chillers. We have low pressure and high pressure chillers. These are going to be used in large commercial buildings, high rises, large campuses. And what these do, it uses chilled water versus refrigerant to remove any heat in the building. So what the chiller will do is drop the chilled water temperature. All depends on the application, anywhere between 40 and 50 degrees on average for a commercial building. And that water is pumped through an air handler. And just like we talked about these VAV systems, this would be another part of that VAV systems where we're pumping the chilled water through a cooling coil, and then the air moving across that coil will remove any heat from the building as it's recirculating. The chillers they do require other pieces of equipment that we're going to get into, the cooling towers, and then we're going to have a couple sets of pumps. We have chilled water pumps, we have condenser water pumps, and then we'll have the tower. And then another component to that is the air handler, and then all of the VAVs that are served from the air handler. Like I said, we have some high pressure and low pressure chillers. On the low pressure chillers, they actually run in a vacuum. So when those start to leak, they'll actually pull air into the system, and then we'll start to create, issues with running high pressure trips, things of that nature. On the high side, it's more of like a positive pressure, just like we have on RTUs. Different types of refrigerants are used on the different applications. But they all accomplish the same thing, provide chilled water to the building. These also can be controlled different ways. Obviously, we can use variable frequency drives to ramp up the compressors. So obviously all the new chillers now are going to be all variable frequency drive. There's still a lot of old chillers out there that are across the line, and then some that have been retrofitted with variable frequency drives. These will actually, you have a longer life with a chiller, and obviously proper maintenance and water treatment. Water treatment is a big deal with these, maintaining the proper levels and keeping any corrosive properties out of the water are important. There are copper tubes that run in the chiller barrels, so we don't want any scaling or buildup in there, because once we start having that, then you start losing your heat efficiency in your heat exchange.
Next slide. Yeah. Yeah.
What's that?
No, just making sure we're on the next slide.
Oh, okay. Well, which are you? You still on the chillers?
Cooling towers.
All right. Well, let's go back one slide. I just touched on the water cooled chillers, and we also have air cooled chillers. On the air cooled chillers, that's going to be the chiller on the left hand side, where instead of a cooling tower, it's going to use refrigerant with condenser fans to remove the heat. So on the unit to the left, you'll see 6 fans, and that type of system does not require a cooling tower. Generally going to see these on the outside of the building, either floor level or on the roof. And like I said, the chiller on the right, you'll see those generally in a mechanical room inside the building, and then you're going to have a tower as well, that generally pretty close to the chiller on the roof or ground level.
Well, and I see on the bullet points you've got availability listed. Could you talk a little bit about some of the challenges right now in the supply chain that are affecting HVAC and the lead times?
Yeah, I mean, I think that's kind of across the board with all the equipment right now, materials and parts. But on the air-cooled chiller, those are more of a built kind of ready to go on the shelf product, where chillers are not. Chillers are usually built to the order, and so like I said, for the manufacturer to get the materials, and then even the labor to build these, they're struggling with. So with the air-cooled chillers, there's definitely a shorter lead time on procuring a chiller for that type of application. Also on the air-cooled chillers, they are less maintenance. Obviously less equipment because we don't have the tower and extra pumps that we have to deal with. So it's just a matter of keeping the coils clean. That's always important on any HVAC device. Condenser coils, top of the list as far as one of those things, if not taken care of, will definitely shorten the life of a unit. So keeping an eye on those heat exchangers, whether it be an RTU, an air-cooled chiller, a water-cooled chiller, the components that are exchanging heat are really important in order to maintain the efficiency and the longevity of the unit. So now we can move on to the towers. Like I said,
let me pause you right there. Somebody asked about what were the different types or kinds of pumps.
So we'll have the majority of the pumps that are out there are going to be like a centrifugal style pump. There are a couple inline pumps on some applications, but I would say 90% of the pumps that are being used in these applications are centrifugal pumps. So, and they can range anywhere from 5 horsepower to 100 horsepower. Like I said, just depends on the application, and generally you have multiple pumps for one system. So one or two for redundancy, and then you can also you want to do lead lag, so you maintain equal hours on the pump, and then if additional pressure is needed in the system, depending on the heat load in the building, it might take 2 pumps to move the amount of water needed to satisfy that system.
So chillers now.
Towers?
Sorry, yeah, cooling towers.
Yeah, so like I said, towers is one of those other components that are used with chillers, and then they're also used in the water source heat pump application. Like on a water source heat pump, we use water to remove the heat from the condenser. And so that heat that's being removed from the building will be pumped through the tower. And then as it makes its way through the tower, there's a couple different styles. We have closed loop and open loop towers. The one in this picture is an open loop. You see the water is returning into the top of the tower. And then it is, kind of raining down into that basin. And then we're pulling air across that water and to remove the heat. And then as the water leaves, we generally have about a 10-degree differential between supply and return.
So next slide, right there.
Yep, that's it. So I said there's a couple different types of cooling towers, and this one is for any type of, like I said, condenser system that we have a that's not air cooled. And then there's also towers for DX systems where we have a refrigerant coil that runs through the tower. And then the same thing, we're on that closed system, we have a basin full of water. We have a pump that's on the side. We'll pull the pump, we'll pull the water out of the bottom of the basin, and then run it over the top of those DX coils, and then removing the heat that way. So a couple different types of towers. Obviously, they range in size depending on the tonnage and location. Obviously, more cooling towers aren't as efficient in humid areas. So you'll in those humid areas, you actually have to oversize the tower in order to do the same amount of work as a different location with a lower humidity. Same thing. Water treatment is really important. Since we are doing heat exchange, all the solids from the water will attach themselves to the coils, to the heat exchanger. And so proper water treatment is important for the longevity of it. Obviously it's kind of a wet environment. So we have a motor, there's bearings, belts. So these things need to be kept up, grease the bearings, checking the belts, keeping the motors, free of any dirt. Any dirt will attract the moisture and then, prevent motor failures. And then obviously if we're not greasing the bearings, we'll have bearing failures. Towers, same thing on the lifespan, 15, 20 years is pretty good. There's always those variables, runtime and conditions and preventative maintenance.
So it really sounds like, just kind of taking a really top view, is that the HVAC systems in general are very mechanical, and as through the years and through more efficiency, we're adding more electronics and more things to control them to provide a higher level of efficiency, and while at the same time trying to keep things clean so that they don't fail sooner than later.
All right, we'll move on to the next one, package VAV units. This is what we call a package VAV unit, sometimes referred to as a boxcar unit. Essentially, it is a big rooftop unit, but on these, generally, we're only doing cooling only. So this will have the same components as the RTU. We have our compressors, we have our condenser coils, evaporator coils, supply fans, our controls, and then what these also will have is economizers for outside air. If you're not familiar with an economizer, we use those if the outdoor air temperatures are lower than what our set point is. So for instance, if we have, say, a day where it's 60 degrees outside and the building's calling for mechanical cooling or some type of cooling, if that temperature is lower than our set point, usually somewhere between 62 and 65 degrees, then what we'll do is we'll open up the outside air dampers, and instead of running that mechanical cooling, we'll pull the outside air in and use that 60 degree air to cool this space versus mechanical cooling. So and they'll also work in conjunction with each other if the outside air isn't enough to satisfy the space, then we'll start to bring on mechanical cooling. But economizer is a great function for energy efficiency. We sometimes refer to as free cooling. What these units will also have are static pressure control. So as we bring in more outside air into the building, and this is kind of important now too with some of the things we see with COVID, a lot of the buildings are increasing the amount of outside air they want to bring in, because the more outside air, the more air changes we're having inside the building, and so it's more of a fresh air. We don't have, you know, a stale air. There's obviously Title 24 regulations that you know, we should know how, or kind of dictate how many air changes we need to have in a building per code. But now what a lot of customers are doing is wanting to, you know, increase that number, sometimes 10 times what is actually needed. So that creates some issues. The more outside air we bring in, the more air we need to remove from the building, or what happens, we start blowing doors open. And that's kind of one of the balances we need to find is when we start to open up the outside air more, they said we start to pressurize the building, so that air needs to be exhausted. And on top of that, even with customers wanting more outside air throughout the year on those warm days, you know, we got to remember, if we're bringing in 50% outside air and it's 90 degrees, we're trying to cool that 90-degree air back down to say 55, 60 degrees. So it does put a lot more load on the system, and obviously energy costs will go up because we're having to cool this warmer outside air to get those the more air changes per hour. So this will be this is basically the air handler, and this will be providing the air distribution down into the space.
Next slide.
Yep.
And I think it's a better representation of what's going on, maybe.
Yeah, absolutely. So from the ductwork on this VAV unit, it runs down, and then we have a main branch. Off of that main, we'll have VAV boxes, and the amount of boxes per floor will vary, obviously, depending on the size. But I'd say on average, you know, most buildings I see, we have about 30 to 40 VAV boxes per floor. And then each box will control a zone. It could control maybe just one office. It can control 2, 3, 4, 5 offices. It all depends on how the building is designed. Generally, we don't see any more than 4 offices off of one VAV. And the reason for that is that one VAV has one sensor, and that one sensor is going to be in one of those 4 offices. So,
well, and Jason, isn't that how some of these like the calls for I'm cold, I'm hot, like what's your experience tell you here? So as a facility manager, what should they be looking for so that they're making good choices when things are being, you know, tenant improvements are being done, and they're looking at blueprints and they say, oh, I wonder what Jason would do.
So, I mean, I would put a VAV box with a reheat coil in every single office, and then you'll never have a complaint again. But that is not you know, within the realm of you know, being or trying to save some money, because it's really expensive. But you know, it varies. Obviously, different people have different temperatures. I think one of the things we see on some of these office spaces, you'll have multiple tenants within one office, and so one person will have basically, you know, whatever's going on in their area and their office will kind of dictate what's going on in the other offices. So some things we see is they'll have an employee in the office with the thermostat that maybe is only there 1 or 2 days a week, where the rest of the offices are occupied, say 8 hours a day. And what happens is there's nobody in that room that has a thermostat. They're not generating any type of heat load. You know, the lights are probably off, computers off, you know, the blinds are closed or the shades are down. So what happens is those other areas will start to, they're warming up, but the office of the thermostat in, for all intents and purposes, that's satisfied. So there's no reason to dump any more cooling into the space.
Yeah.
So I guess, when you're looking at those areas on the zones, knowing, how often somebody will be there, the location. Another thing to always look for that we see quite a bit that kind of throws the system off will be there's, like I said, there's a sensor on the wall. And we see a lot of times that there'll be a computer screen right up against a sensor, a copier, a water cooler. All of the heat that those things generate will throw that system off. It's making the system think that it's warm in the building, and so it starts to dump a ton of cool air in. So location is important. And then, it's kind of hard to say. I mean, everybody's so different as far as temperatures. So there's always a little bit of comfort balancing that has to be done, to maybe damper down some of the air. I said, if you have multiple offices and three of them.
So when you say making those adjustments, like damper down the air, is that something that a facility, like an engineer, a building engineer, a day porter, what kind of job category would be able to do that functionality? Or do I have to call someone like Air Control Systems to take care of that?
I mean, a building engineer, obviously with enough experience and understands how the system works, would they would be capable. But yeah, I mean, usually we get the service company involved, because you start making too many changes, and then you start to throw the whole system balance off. So knowing really how much to adjust, and then knowing what the effects are going to be. Like I said, if you have an area in the summer and maybe one person's cold, and so they don't want as much cold air, but the rest of the employees that are off of that same zone, they might be comfortable a little on the warm side. So we can damper down that one office and slow the air down, so we're not pushing so much cold air into it. But on the flip side, once we go into those cooler months and then we start to need heating, well, most likely if this person is cold in the summer, they're going to be cold in the winter, and then with that damper being closed, they're going to be starving for that warm air that they're looking for the reheat.
Yeah.
So it's one of those things that you kind of just got to make small adjustments, and then just understand and always have a conversation with the customer. That this isn't the ultimate fix. This is more of a kind of a temporary thing to make the space a little bit more comfortable. So back to this VAV. So as we have air, we're going to have the airflow from that VAV unit, and it's going to be entering in the left side of the VAV. At the number one, we have a velocity sensor. This is going to measure our airflow. Each VAV is basically designed and going to be programmed to provide a certain amount of minimum air and cooling, minimum air and heat, maximum air and cooling, and then a maximum air and heat. So all these are programmed, and that sensor will measure that flow, report back to a controller, which will proportionally adjust the damper to the CFM needed. Like I said, that damper is constantly moving, and so on that VAV system, so it's called variable air volume. That volume is always changing. So at the rooftop level, at the unit, that's always looking at basically the duct static, the pressure within the duct. And as these dampers open, that pressure in the duct will drop. The VAV or the supply fan will ramp up to compensate for that. And then as these dampers start to close, the pressure starts to increase back in the duct, and the supply fan will slow down a little bit. Just so what we're trying to do is maintain a constant static pressure to all the devices in the building. So no matter what position that damper is in, it always has enough air to provide into the space. If we don't if we have too low of a a static pressure in the duct, and you have all these boxes, say, going into cooling, and we have a hot summer day, and there's not enough pressure, we're not going to be moving enough air into the space to to provide cooling.
But isn't this what is also the sounds like the opposite problem when you're blowing the doors open, that you have this inconsistency between the variable air volume and the VAB boxes, and then the makeup air, or the air from the what's it called? Sorry, makeup air from the package unit, okay, trying to make up for it, and then you have the system's out of whack, so it's blowing the doors open or sucking them closed, however you want to look at it.
Right. So yeah, within that VAB, it does have a static pressure control, which it monitors. The unit monitors two things. It'll monitor the duct static and try and maintain that pressure within the duct, and then it's also looking at building pressure. And what will happen is that building, but we always run a building just slightly over positive. We don't want to run it into a negative, because then, a slight negative, you won't notice anything, but you'll tend to pull a little bit of, obviously dirt and debris from outside the building into the building. Yeah. So we keep it slightly positive, and not too much to be blowing the doors open. And then on the negative side, so what will happen is when you have some building pressure issues, you have two things that happen: either blowing the doors open, or the doors are being kind of the building's in a vacuum, so they're being held closed. So that's where that static pressure control comes in, to maintain that. Like I said, the building pressure is too high. Then what it'll do is open up some dampers, and run an exhaust fan to pull the air out of the building to drop that pressure down. Same thing if the building starts to run into a negative, in which none of these things should happen if everything's working correctly and set up correctly. But
let's take that concept of the airflow and the volume of air and jump to slide 16, which is the COVID and return to work.
All right.
So I was helping Sergio earlier, and so we were coming up with some ideas related to the return to work and where people are in that process. And a lot of the conversation was related to the air exchange rates, what people have done regarding portable air cleaners, what people have done regarding their MERV efficiency values, and then, how long do these measures need to stay in place? And when we were originally talking about it, the wildfires were going on also. So that was one of the other conversations we had. So if you could maybe talk to some of these bullet points related to what you've seen in the marketplace and what's gone on, so that people can understand, maybe from a best practices standpoint, what do you recommend? What are you seeing in the marketplace?
Yeah, so I touched on a little bit earlier. Obviously, more outside air is the number one, right next to, well, I would probably say filters are number one, and then increasing our outside air. So what that's going to do, when we go to a higher efficiency filter that's going to catch more particulate, you also have more restriction on the airflow. So two things will tend to happen right now is a lot of buildings are wanting more airflow and a higher efficiency filter. What that will do is, the more outside air, obviously the more dirt we're bringing into the unit that the filters are going to catch, and that creates an issue with maybe our filter changes. Used to be quarterly, now we have to do them monthly, bi-monthly. It all, like I said, it all depends on the runtime, and then how much outside air we're actually bringing in. But definitely more outside air. And then customers are also wanting to run the equipment at night, just to keep, the equipment generally shuts down, say 7 o'clock, and won't start up until, 4, 5, 6 o'clock in the morning. Well, what they're wanting to do now is, let the units, say, shut off at their normal time. And then at sometime around midnight, they want to start them back up and go into that economizing function. So bringing in outside air and then removing any air into the building. kind of doing that as an air scrubber, just to keep that air fresh.
Yep.
Along with a lot of the portable air scrubbers that we're starting to see inside a lot of the office spaces that our customers are using. Yeah, like I said, a big thing is the air changes. Customer also wanting to know how many air changes they're having an hour. They'll have maybe some outside consultants coming in and putting together an action plan to increase the air changes, or at least to know that we're doing the minimum, if not more, increasing the efficiency of a filter. And like I said, let me touch back on that outside air. There's a fine line on, it'd be great to bring in 100% outside air all the time and keep those air exchanges at the maximum. But like I said,
that's unrealistic, right?
What's that?
That's unrealistic, right?
It is, yeah. And like I said, with the weather changes, it just wouldn't be able to probably keep up with the load without having a lot of issues. And then obviously humidity is a big factor into that as well. So the type of sensing that we do to enable economizers is outside air temperature. But another thing, the next layer to that would be looking at the moisture in the air. So if we're bringing, that the temperature might be low, but we have more moisture in, which then starts to make the building feel kind of sticky.
Yeah, we've had a lot of humidity.
Yeah, so things to look at and to think about, and what type of system you have and what it's capable of monitoring to keep it as comfortable as you can within the building.
So I see in the slide it talks about most commercial HVAC systems can handle going from a MERV 8 to a MERV 13 without challenges. So does that mean that they have, like you kind of mentioned, if they go from an 8 to a 13, do they need to do more service, or is it just or a quarterly service would still be sufficient?
It's hard to say. Okay. What I would always say is, we just need to kind of monitor it. So once we, add the filter to it, we keep our say our quarterly maintenance program, and then, we rely on the technician to look at the condition of the filters when they do that next maintenance, and bring it to everyone's attention that the filters are plugging up a lot quicker, and they should be changed more frequently. Like I said, that's something that we definitely rely on the service technicians to to bring that to our attention in order to either increase the frequency, or we can just keep the frequency at the same. It all depends on the area and runtime.
Well, and we do live, in Orange County and all of Southern California, and we have a lot of grasslands. Occasionally we get wildfires. So wildfires near my building, Title 24 and economizer. What would you recommend to a facility manager who has maybe a wildfire near their building? Open up those economizers and just draw the air in? No.
No. Yeah, generally we get those calls all the time when we get the fires. I mean, obviously, depending on how far away or how, whatever your distance to the fire and how you're being affected by it. Yeah, a lot of customers will ask to shut the economizers down. And so we're not bringing in that outside air. We haven't had to cross that road yet with fires and, COVID, because it's kind of a touchy, area with not having any of that fresh air, but then also, keeping any type of smoke out of the building. So I said it, not something I've had any experience with, but yeah, it is, something we do quite often with fires is disable economizing, at least until the areas are, clear and we can start bringing in that fresh outside air in again.
I think the next question kind of leads into our next slide, which is related to risk management, mitigation, and COVID. But the question is, for the next slide, is would you put in EV and or bipolar ionization or other air purification technology, and any recommendations as well.
Yeah, yes, we've been doing a lot of the, ion, UV lights. I mean, there's definitely benefits to it. And then, of course, like I said, we are seeing anything that we can, or that, that we can do to improve air quality, especially in these times, is going to be big. And so technology has come a long way, and these systems are proving to be more, reliable and to actually catch more, or kind of, disinfect that coil and prevent any, the biological growth on there.
And so preventing that biologic growth, and the UV lights do have they have a life to them. And so the question that I added in here was, how long will the COVID changes? So if someone moved down the road and they put in MERV 13, they're doing additional exchanges, and now they've got 6 months under their belt, and maybe employees have come back or maybe not. How long do you think these COVID changes will last? Do you think it's here to stay, or is this something that you believe will change back to older habits over time?
I think it depends on the customer. Obviously, like I said, I do think this will continue on. I don't think it'll change too much, but I do think some property owners, managers, are going to see the increase in energy costs. In order, for this higher efficiency filter, for more unit runtime for the outside air. So there's some that might, if they this fizzles away and is not in our face every day, then there might be some customers that want to put things back to the way things were, where we're still we're still bringing in our minimum outside air, we're still meeting our Title 24 requirements, but obviously that'll help them save some money, and it could be a fair amount of savings depending on the size of the buildings, how many buildings you're running. And I've seen a lot of customers that have done this, are already maybe questioning how much we need to do because of the added expense. Like I said, electrical bills definitely have gone up, and so now they're starting to look at different ways to improve or to increase their energy efficiency and lower their costs.
Speaking of lowering costs and finding out new ways, I think, going on to the next slide of preventative maintenance, that's kind of the quarterly check to see how things are progressing with your equipment. So if you want to talk a little bit about a preventative maintenance program and what to look for.
Yeah. I mean, so obviously, number one is going to be the service provider and what they're, doing for the customer. The goal is to be proactive instead of reactive. So keeping the equipment at its peak performance, looking for anything that could be a potential failure. So we want to catch that, or those types of issues before it's a problem. I mean, obviously, if we can, if we recognize something that could be failing, and we can get that replaced on a scheduled breakdown versus a unscheduled issue or service call, and of course that always happens in the middle of summer in the worst possible times. So being proactive, communicating with the property manager, looking for different ways to increase energy efficiency. Obviously, the evaluation for retrofit, like we talked about, variable frequency drives, and how that can help lower the energy costs, upgrade possibilities, and obviously I'm the controls guy, so I'm all for building automation, be able to monitor the systems. You can make changes remotely. A thorough company that is, going through all of the equipment, looking for, the signs of units not running at their peak efficiency. Those are all going to be, benefits of the PM. Another thing, looking at the type of equipment, each piece of equipment does not always require the same amount of maintenance intervals, or maybe will require annual inspections on some of the larger equipment, that we're not just looking at a quarterly inspection, that we're doing the same type of inspection, the filter replacement, the operations checks, the cleaning. Sometimes these equipments like the chillers, the towers, they require more of a comprehensive inspection, at least yearly. So, I say you got to look at the whole picture and put the best package together for the customer.
Sorry, I dropped off. I'm joining back. Hold on.
All right, so like I said, we kind of touched on that, what to look for in a PM program. Like I said, obviously, communication is key, to let the customer know, and that just doesn't go for the equipment itself. We're the ones that are on the roof at the equipment, inside mechanical room. So it's up to the service technician to basically capture everything. It might not just be the piece of equipment. It might be a roof drain that's plugged. All of these things, like I said, the service tech is usually the only guy on the roof, and so it's up to him to keep the customer informed of what's going on. Obviously, proper training for the technicians is always important. And like I said, reporting those items to the customer, and then providing solutions and proposals to replace or repair that equipment. So we talked about filters. I said we have different types of filters. Obviously, there's the fiberglass. I think we've all seen those. It's probably most residential homes have these fiberglass filters. Fiberglass gets shipped out with any of the new equipment, and those are just temporary. Those are usually pulled right out and replaced with a pleated style filter. The MERV ratings that we're talking about, the efficiency of that filter and how much particulate it's capable of capturing, and then of course HEPA filters used in the medical field. On the HEPA filters too, those are being monitored through a pressure differential. So we got to look at the pressure drop across those filters in order to determine the frequency at which to replace them. So on our general maintenance, we're going to be replacing filters quarterly. MERV filter or the HEPA filters don't need to be replaced as frequently. And like I said, we just have to monitor that differential, and then once it hits that limit, then those will need to be replaced. But generally, yeah, MERV 8 and 13 filters are generally what we're seeing on all of our commercial properties right now. Any questions on the filters?
Yeah, any questions on that? Sorry, everyone, I had to jump off the call. I'm audio only
now. Nothing?
Well, and I think as we're kind of wrapping up our time here, we certainly want to know that you're available for questions. You can direct them to me, and I'll do follow up. Here were the links that we had worked together to develop the presentation and share. And we hope that you are able to join us again, unless, do you have any other comments or questions? Otherwise, I'm going to wrap it up. I see that someone wrote a message. Hold on. I can't see it now. Can you see what that question was or that comment?
Sure. It says, how long do you foresee supply chain issues impacting filters? It seems like it takes a long time to get your hands on the MERV filters.
That's correct. And, I'm not sure. And a lot of our suppliers, or I think we're all kind of in the dark right now, as to when, we'll kind of get back to normal and we can get, parts more frequently. It's hard to say. I mean, I'm sure we're going to be in this situation for at least another, 4 to 6 months. So, like I said, that is always going to be, or that's going to be something we're going to have to deal with for a while. And then, like I said, obviously with the MERV, 13s that we're using now, or that a lot of buildings are going towards, materials aren't there, and then the labor to produce things aren't there. So, like I said, I kind of foresee at least 4 to 6 months. And obviously, as that time goes on, it should start to taper down a little bit. We're obviously finding different ways, to address this, and different manufacturers, to aid in that. But yeah, I mean, kind of what I see and what I've heard in some of our distributors, it's probably 4 to 6 months. Any other questions?
I think that's it. I want to thank everyone. Jason, I really want to thank you for stepping in today. Those are fast and furious shoes to fill. Again, follow up with myself if you have any questions, and I'll get them answered for you. And please join us next month. We will have another Orange County IFMA business partner presenting on a fun and exciting topic related to facility management. With that, thank you very much, Kristen. Thank you for taking the reins and making this happen today. And with that, everyone have a good Tuesday and the best of luck.
Thank you, guys.
Thank you.